and welcome to the Daily Space Weather. I'm your host, Dan, aka smAsho. And we're looking at the sun here in 193 angstroms from the Solar Dynamics Observatory as a coronal whole wind sputtering high-speed stream arrives. We see a series of sunspots setting in the southwest and an active region rising in the southeast. Here's another wavelength of ultraviolet light, 171 angstroms. And we'll also show you ionized helium, 304 angstroms. All of these animations are from the SDO, Solar Dynamics Observatory. 0 sunspots. Here's a diagram of the solar system. We'll advance this 1 week. There's where things will be in a week. New moon approaching. Here's a star chart. I've faced mine to the south and drawn in the ecliptic, which is this yellow line, the sun's path across the sky. It's in the-sky.org. If you're wondering the website, you want to make your own star chart. And if you follow me on Instagram, you may have already seen this imagery of the moon, the gibbous waning moon from this morning, along with some clouds here from Lehigh Valley, Pennsylvania. Instagram.com/smAsho. Exclusive content there. The 10.7 centimeter radio flux, the upper chromospheric and lower coronal radio output from the closest star at 72, having dropped an additional solar flux unit from yesterday. There's the 1-year chart of that. The black line is the radio flux. The red line down here is the sunspot number. And NOAA is forecasting periods of geomagnetic unrest for the next 3 days. So you can see these every time you see a KP4 here, every number 4 there, that's a geomagnetic unrest period. And it's from the incoming coronal whole wind stream. Let's take a look at what earthquakes have been shaken over the past 24, and it looks like not very many. Although there was a mid-5 level quake at Vanuatu at over 160 kilometers depth. Also one at the Philippines at a similar depth and magnitude. That was a 5.1. And at 167 kilometers depth. Also a deep quake struck Fiji, 569 kilometers down at a 4.1 magnitude. New Zealand also saw a 5.2 in the northeastern portion of the North Island. The largest quake of the past 24 must have been this 5.8 at Chile. And here's a quick view of the location of that, right on the coast, in a little bay there, near Coquimbo. Volcanoes. Suwanosejima been exploding, or at least it exploded yesterday at, actually early today at 1:53 Universal Time, produced a 4,000-foot plume of volcanic ash. Dacono on Halmahera has exploded. 8,000-foot ash plume there. Samisopochnoi, residual low-level volcanic ash emissions there. In the Aleutian Islands, Popocatépetl, sporadic emissions as it mildly explodes. And Sabancaya exploding as well in Peru, producing a 21,000-foot ash plume. Please do not pole vault the caldera. This public service message brought to you at massive personal risk and expense from smAsho.com. Please support us via our links below the video. Next, looking at solar flares. We don't see any major ones, although a couple of B-class flares in the past 3 days. There's the 3-day chart as reported by the GO-16. No proton strikes, no surprises there, no major coronal mass ejection strikes, just a minor one. Next, the GOES magnetometer. And you can see quite low readings here. Most recently making it down to about 50 nanotesla. And we're expecting a precipitous uptick in this. Look for spiky GOES magnetometer readings over the next 3 days as this sputtering coronal whole wind stream is going to make this thing go all over the place. Here's the magnetic environment associated with the heliospheric current sheet, and we are expecting to see the Earth in the South Pole oriented current sheet by tomorrow. So the North Pole portion of the current sheet is shown here in green, South Pole shown in red, and you can see Earth's potential field surface source line there shown in orange. We'll be arriving at the South Pole current sheet quite soon. This data is derived from stereo A magnetometer, stereo B magnetometer, and 51 ground-based magnetometers. It's all part of the National Sunspot Observatory. Here's another view of the same data, the line of sight ecliptic plane field plot. I'll let it play through a second time. And last but not least, the line of sight coronal hole plot. And we're going to see coronal hole winds here from two different coronal holes. One is a South Pole oriented one, but the first one is a North Pole oriented one, shown right here. So we're going to see two different polarity coronal hole wind streams showing up here around the same time again over the next 3 days. And it's going to create lots of, again, spiky readings on the GOES magnetometer. And here are the sunspot groups and coronal holes from the Integrated Space Weather Analysis Center. Returning to 0 sunspots today. And those coronal holes are actually quite diffuse. They've actually been degrading also over the past couple of days here. The KP index is at 3, lower than NOAA's forecast. Don't be surprised to see this go into geomagnetic unrest conditions of a KP4, again, over the next 3 days. Next, looking at the real-time solar wind. Current conditions are solar wind density, 10.5 protons per cubic centimeter, solar wind speed 349 kilometers per second, and we're expecting much bigger spikes in both the density and the speed here. Expecting a coronal hole wind stream of about 550 kilometers per second after we see additional spikes in the solar wind density. The signature of a coronal hole wind stream. Next, the magnetohydrodynamic pressure here in nanopascals. It's 4 hours of data of what's been going on in the magnetosphere. A fairly steady wind over the past 4 hours. Here's ground magnetic perturbations, otherwise known as geospace delta B, changes in the Earth's B field. And there is a polar excursion going on, folks. The geomagnetic situation on Earth is tenuous. We've got 2 North Poles, and the South Pole is someplace south of Australia, thousands of miles from the South Geographic Pole. Anyway, there's 4 hours of data on that. If you weren't aware, we're also on BitChute, thanks to our BitChute subscribers. We regularly stream live to Twitch, although not today. And thanks for everybody viewing on YouTube. Don't forget to press like and subscribe if you're new to the channel. Press share, press like, leave us a comment. Tell your friends, foes, and neutrals about the channel. And let's do a cosmology segment. Today's will be short, and it will be exclusive and only in today's Daily Space Weather video. Today's astronomy picture of the day is the Carinae Nebula. So the Carinae Nebula, the location of, I believe, the largest star known, Eta Carinae, which is a very large and very unstable star. And what you're looking at here is hydrogen, sulfur, and oxygen. So the hydrogen appears green, the sulfur appears red, and the oxygen appears blue. So you're looking at a spectral analysis here where we've colorized the chemicals for specific spectral emission lines, the Carinae Nebula. And you can look at the astronomy photo of the day yourself at apod.nasa.gov. So Eta Carinae, a very interesting star. It's very unstable, very, very large. The amount of gas being carried away by the wind, the stellar wind from Eta Carinae, is equivalent to 1 sun every 1,000 years. While this, quote, mass loss, end quote, may not seem very large, in fact, it is an enormous rate among stars of all types. a very faint structure seen in argon is evidence of an interaction between winds from Eta Carinae A and Eta Carinae B, the hotter, less massive secondary star. And you're looking at here chemical spikes in the emission spectra. You can see these spikes in argon here. Eta Carinae. So there's nothing random about that. And here is the Finkbeiner data on the Carinae Nebula. And you can't even really see Eta Carinae there. It's a giant blob-like cloud of hydrogen, which is what the Finkbeiner is. And if you look at it in X-ray, it's going to look completely different. I can zoom way, way in the X-ray band to see the location of Eta Carinae, a super ultra giant star surrounded by a massive cloud and nebula. And let's take a look at it in infrared light. There you can see it's a very hot portion of the galaxy there. Another type of infrared there, the all-wise. And you can see it is close to the galactic plane. Let's see if we can get it in blue light. There it is in blue light. The Carinae Nebula, featured in today's astronomy photo of the day. And that's today's cosmology segment. Let's continue on as we've got some more space weather data to show you. So here's the electron flux over the past year. That's from Solon.info, solon.info/solar. Great data site. Here's the 3-day chart. And we're seeing the electron flux crater here as the coronal hole wind stream arrives. No surprises there. We do see some charging hazards. That's a bit surprising. Charging hazards there located around Mexico, Central America, and the Central Pacific. Surface charging. Here's the forecast model for the electron flux. And I would tend to agree with this forecast model here. The green boxes are the forecast. The yellow diamonds are the observation. Here's a diagram of the Van Allen belts. Feel free to pause the video. Here's a visualization of the total electron content forecast, showing you where most likely GPS errors would occur as your GPS handset has to communicate with a satellite. And there are lots of electrons between you and the satellite. We're seeing very anomalous electron flux here, especially over places like South Central Africa. You can see some anomalies there. And I would remind our viewers that we've got 2 Atlantic anomalies now. One is about here. That's the South Atlantic anomaly. But it has recently split. And there's also a South African anomaly as well. And you can see some evidence of the location of those weak spots in Earth's magnetosphere. Here's another diagram of the atmosphere. I would note this F right here. Don't worry, you're not F'd. It's just the F ionosphere layer. And here is an animation of that. We'll let it play through. Would not be surprising to see an anomalous ionosphere, and indeed we do see an anomalous ionosphere. If you don't look at the videos daily, you may not understand what I'm talking about. Maybe we'll do a video completely about the ionosphere. Keep in mind the resolution of this imagery is only 1 megahertz. You can see on the right there the scale, 1 through 14 megahertz. It's the vibrational frequency of the activity going on in the ionosphere, where there are lots of chemical reactions and other things happening at about 300 kilometers of altitude. Anyway, here's the latest image coming in at 10 o'clock Universal Time today. Looking a little anomalous if I had to comment, which I don't. Next, looking at the surface winds of the Western world. There are the surface winds. How about the jet streams? And it's a meteorology segment. This will be a YouTube exclusive also. This will only appear in the daily space weather video. Anyway, there's the jet stream scenario of the Western world. Quite chaotic once again. Here is the Eastern world's jet stream scenario. Looks like some cold weather there, striking especially southwestern Australia. And some big pressure gradients most likely being made in this area with these big kinks in the jet stream. Let's see what's going on with lightning. Excuse me. And here's your real-time lightning map. It's lightningmaps.org. And we'll take a look at a close-up of the United States. Heavy lightning here off the Gulf Coast of Texas and also in southern Louisiana. As this series of moisture and systems, this is finally starting to make a move. And we'll show you some more data about that. But first, we're on windy.com. I'm just showing you the windy.com sulfur dioxide map. This shows you the location of volcanoes such as, I don't know, Hawaii. Hawaii breathing out lots of sulfur dioxide. As you can see there, one of the top producing sulfur dioxide locations on Earth. And I believe this is actually Sabancaya down here. Anyway, windy.com, they've got a great mobile app. Here's a U.S. Doppler radar map. And Louisiana almost completely inundated with heavy storms, and it's going to continue here as this system is moving to the northeast. There's going to be a little bit of training associated with this as it's all moving in the same direction as it is oriented. Here's the cloud layer. Here's the water vapor map. We do have a little bit of an impulse here behind this moisture, some dry massive air, although it is hot air, so it's not as massive as if it was cold air. Anyway, again, there's the U.S. Doppler radar. There's the cloud layer in 3.9 nanometers radiation as water emits radiation. And here is the water vapor map. Here come bonus features. How about the El Teide, Spain hydrogen alpha imagery in 6,562.8 angstroms? I would note there is still a possibility for coronal mass ejections, folks, as we've got massive quantity of filaments down here in the southern hemisphere. Less so, but some filaments as well in the northern hemisphere. And I want to go back to the Integrated Space Weather Analysis Center to take a quick look at Stereo A's coronagraph. Likelihood of coronal mass ejection in the Earth-facing vicinity is very high right now. That is likely to eject or collapse in the next 24 hours. Don't be surprised to see that happen. Thanks to the Smash team. Thanks most of all to our patrons. Patreon.com/SmashoMash if you'd like to support our efforts to do things like forecast coronal mass ejections before they occur. I'm not aware of anybody else willing nor able to do so. However, we have demonstrated time and time again that we are able to do so. Patreon.com/SmashoMash. Here come the rest of our bonus features. The colorized magnetogram to show you 0 sunspots and 0 areas of magnetic organization. The intensitygram, again, no sunspots on the visible portion of the solar disk. Here's the southern hemisphere, the setting regions of sunspot 2018, 2818, 2820, and 2821. How about a close-up of that? And there's your close-up of those most recent 3 sunspot groups. And let's close things out with some imagery of the rising active regions in the southeast. So we'll be watching that. We'll be watching the coronal hole wind stream and that filament you see in the Earth-facing zone we just showed you from Stereo A. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics. Welcome to the Neo Renaissance. Visit our links, support our channel, and since it'll never be now again, may that solar wind be at your back.